So moving on with our next operation, we have this retrieving the ith node in a single linked list. So ith node that pertains to the desired location or desired number of position of a certain node. So let us say, as you can see, as you have noticed, we have here node pos as a variable that would specify the position of the element that we want to retrieve. Okay, and the head is the address of the first node. So in our given example, we have here our linked list. Okay, so here is our linked list at the lower part. Head, the address of the head is 12H. Okay, so 12H, we have to test first. Okay, we have to trap if our head is not equal to null. That means we have to test if if we have a an empty list. Okay, so if head is not equal to null, if this is true, that means we have elements of a single linked list. But if this yields to false, that means we don't have an element in the single linked list, or simply saying that the list is empty. Okay. However, in our given example, we have here the address of our head is 12H. So 12H not equal to null. Is 12H not equal to null? Okay, so 12H not equal to null, true, because it has element. Okay, so it has element. So this is true. So if it is true, you have now to set the value of count to 1. So it's like saying that instead of the word set, we are assigning value 1 to count. So initial value of count, so we have here in our memory, we have count. Count is equal to 1. Okay. And then we have here next node. So we have initialized the value of our next node. Next node is equal to head. Okay. So next node is equal to head. That means the address of next node is the address of the head. Okay. So that's the initial address of next node. So next node is head. So the value of our head or the address of our head is 12H. Therefore, next node is 12H. Hindi siya mukhang 12. So we have 12H. Okay. Next. While count is less than node pos. Okay. What's the value of our node pos? Let us say we want to retrieve the second element. Okay, so that would be our I. Okay, node pos is now equal to 2. We want to retrieve the second element. Okay, so node pos is equal to 2. Now, we have to check, okay, is count less than node pos? Count is 1, node pos is 2. Is 1 less than 2? So that is true. This is true. Okay. And next node is not equal to null. Remember, if we have compound condition and it is connected using AND or AND, that means we have to satisfy both conditions. So we have to test. So after testing the first condition, even if it is true, we have to test the second condition. Okay, so next node is 12H. Now 12H is not null. Is 12H not null? Okay, 12H. 12H, this one, not null, so that is true. True and true is true. So the entire compound condition is true. So if it is true, we have to increment count. So count will now be incremented to 2. Okay? Next, set count. So we have to uh, set count to, set next node to next node referencing to node.link. So that means we're going to assign next node referencing to node.link to next node. Okay, again, next node is 12h. Okay, and node.link of 12h. Okay, so 12h node.link. So that means that refers to 20h. So 20h will be assigned to, and 20h will be assigned to next node. So next node will be 20h. Okay? Next. So the while condition is hanggang dito lang. So we have to go back to the while condition. Okay? So again, we were going to test a new value. Okay? The value of count now is 2. Okay? And our node pos is 2. Is 2 less than 2? Very good. So that is false. Once we have false condition, or we have false value in AND condition, automatic, this will yield to false. So if that is false, go to the if statement. Okay? If next node is not equal to null, next node is 20h. Okay? Not equal to null. Is 20h not equal to null? True. So if it is true, you're going to display, going to print next node referencing to node.data. Next node is 20h referencing to the node.data of 20h we are referring to Louisa. Okay? So we will display Louisa. Okay? So in our output, okay, the output will be Louisa. Okay? Done. Okay? Alright, so moving on with the next process or next operation. Okay? So we have now storing a new value into the ith node. As you have noticed, this is the same, almost the same with our previous operation. Okay, the retrieving the ith node. Now, instead of retrieving the value of the desired position, we have now to store a new value in the desired position. So, same concept, our same process will be done. That means we have to traverse from the head up to uh, the next node, okay, of the desired position. Okay, so as you have noticed, we have here almost the same code until this one, except for this statement. Set next node referencing to node.data equals new value. In our previous example, what we did is we have print, okay? We make use of, instead of assigning the value of the next node referencing to node.data, we simply display the node.data of the next node. So we have this statement, print next node referencing to node.data. Okay? So that is our previous operation. Now, in this operation for storing, so we have to identify the node position. And then once we have identified the node position and we are on that position, we have to assign a new value for that position. Okay, for that desired location. Okay, so we have here so let us try to simulate this pseudocode. Okay, so we have our node new value, sorry, we have the new value, okay, part of the input parameter is the new value, okay, apart from the node pos and our head, okay. So let's have the values. So head is 12h, node pos, let us say we want to store, wala ito, ano, we want to store at position 3, okay, at the third element, okay. So third element, that is our node pos. So node pos is 3, okay. And our new value, so instead of Robert, we want to store Renbert. Okay. So again, we have to test if there is a list. Okay, if there's a list or there's no list, or the list is empty. Okay, now since our given example, we have here a linked list, therefore our head is not equal to null. So 12h is 12h not equal to null. Very good. So that is true. So if it is true, that will happen. We're going to set the value of count to 1. So we have again the variable count, which has an initial value of 1. Okay? And then we have set next node to head. That means the initial value of our next node is the address of our head. So the address of our head is, and then nasulat ni ma'am. Okay. So the value of the head is 12h. So our next node is also 12h. Okay? Next, while count is 1, less than node pos. Node pos is 3. Okay? Our new location or new position is 3, this one. Okay? Okay. And then next node is not null. So 12h. Is 12h not null? Again, that is true. Okay. So 1 less than 3 is true. And 12h is not null. May laman siya. So true. True and true is true. Very good. So if it is true, increment count. So count will now be 2. Okay. Then set next node to next node referencing to node.link. So next node is 12h referencing to node.link. 12h 12h referencing to node.link is 20h. 20h will now be assigned, okay, will now be assigned to next node. So next node will now be 20h. 20h. Okay? Next, we just go back to the while loop, while condition. Okay? Count this time is 2. Is 2 less than or equal to 3? Again, that is true. And next node is now 20h. So 20h is not null. 20h is not null, so true. Again, we're going to increment count, so count is 3. And then, set next node to next node referencing to node.link. Ma'am, pwedeng pagpalitin itong dalawang statement? Yes, pwede naman. Okay? So, pwedeng mauna yung next node is equal to next node referencing to node.link before we increment the value of the count, and vice versa. Okay? So, this time, the value of our next node is 20h. Okay? So, 20h referencing to node.link. 20h referencing to node.link. So, that means we are referring to 31h. So, 31h will be assigned to next node. So, 31h. Okay? Next. we go back to the loop. We go back to, sobrahan ako. We go back to the while condition. Okay? So let's go back to while. While count. The value of our count this time is, let's have other color. Value of our count is now 3. Okay? Is 3 less than 3? Very good. False. Okay? So if we have false in and condition, automatic it is now false. So kung false na yung while, what we're gonna do is go to the next statement, that is if. Okay? We're going to check yung desired position ba ay sakto dun sa ating length of the list. So next node is 31H. Okay? Is 31H not null? Okay, 31H, 31H. 31H not null, so true. So if that is true, then we have to set next node referencing to node.data to new value. Okay, so first we're going to assign the value on the, or change the value on the right side of the equal sign. So new value is Renbert. Renbert will now be assigned to, okay, so Renbert will now be assigned to node.data of next node. Next node is 31H, okay? So 31H referencing to node.data equals Renbert. Again, 31H referencing to node.data, instead of Robert, magiging Renbert. So we now store the new value to the ith node. Alright? So if you have question about this simulation or about this operation, kindly send a message on our group chat or in school book. Okay? In the inbox. Next operation is inserting a node in a single linked list. Actually, as I have mentioned a while ago, in inserting a node, we could insert an element at the head, or we could insert at the tail, or we could insert at any position, okay, or at a certain position. Now, there is a general rule or general procedure that we could follow in any way, in any position that we want to insert the element. Okay, so whether it is on the head or the tail or at any position, this is the general procedure. Okay, so first we're going to create a new node. Create a new node for the new element. Okay, and then set the data field of the new node to the value to be inserted. Okay, so we're going to assign the new value to the node data of the new node that we have created. And then third is you're going to insert the node. Okay, so let's have an example. Let's say we're going to insert at the head of the single linked list. That means if we have a if we don't have the element, okay, if we don't have a linked list, so definitely all you have to do is to create a new node and then assign head for that new node. Okay, so like on the general rule, first is you're going to create a new node and then you're going to set the data field of the new node to the value to be inserted. Okay, and then so these two are the general procedure, and then on the third, actually ito yung third procedure, no? Set the link field of the new node to the value of the head. Okay, set the link field of the new node to the value of the head. So again, we're going to create, let us say, we have an empty linked list. Okay? And then, let us say the address is 1H. Okay? Wala pang laman ang linked list. So, magkikreate tayo ng new node for that element. Okay? So, we have a new node at address 1H. And then we're going to set the data field of the new node to the value to be inserted. So that means, let us say I want to insert A. So all you have to do is to assign the new value A to node.data of the address of new node. Okay, ganun lang po siya. Okay? And then, you're going to set the link field of the new node to the value of the head. Now, since, di ba, we don't have an existing linked list, okay, so initially, the value of our head or the address of our head initially is null. So, head is equal to null. Okay? So, we're going to assign the value of the head, so null, to the link field of the new node. So, this becomes null. Okay? And then, set head to the address of the new node. That means, itong 1H, this now becomes our head. Okay? So, yeah, if we're going to do that, we have head is equal to, okay, the address of the new node, kasama yung word po na address, address of new node, inano ka na lang, address of new node referencing to sorry, yan na yan, address of the new node. Okay? So, let's have this example. Okay, we have, let us say we have an existing nodes of the linked list. Okay, so we have 3 nodes, Armin, Chan, and Renberg. Okay, stored in address 07, 03H, and 19H. Okay, so so let us say we have this example, no? Based on our previous algorithm, okay, we now convert that into pseudocode. Okay, so we're going to insert node at the head. So we have to determine the head, okay? So the input parameter will be the head and the new value, okay? So let us say our new value is Lian, okay? So Lian will be assigned to the address, to the node.data of the new node, okay? So head is 07H, okay? So 07H, okay? So previously, in our given linked list, so 07H is our head. Now, if we will create, if we're going to insert a node at the head, that means we're going to create, the process is you're going to create a new node, okay? So, let's say the address is 05H, okay? And then, we're going to assign new value to node.data, okay? And then, we're going to assign the node.link of the address of the new node to the address of the head, which is 07H, okay? So that we could insert this node as the first element, okay? So that now refers to 07H, okay? So ganun siya kadali. And of course, instead of 07H as the head, hindi na siya magiging head, you're going to assign head as 05H. Ito na. Okay? So, paano yun? Ito po yung kanyang process. Okay? So, first, we're going to create new nodes. Create new node. yung previous net na diniscuss ko ay ito yung mano-mano. Tingnan natin kung magtutugma yung gagawin natin. Okay? So, we're going to create new node. Let us say the address is 05H. Address of new node is 05H. Okay? Yan. After that, we're going to set the address of new node referencing to node.data to new value. Again, yung ginawa natin kanina. We assign Lian. New value is Lian. Lian will be assigned. Okay? So, Lian will be assigned to node.data of the address of the new node. Okay? Again, address of new node is 05H. Okay? Yan yung ginawa natin ngayon. Ito yun, 05H. Okay? So, address of new node referencing to node.data is equal to Lian. Okay? So, Lian will be assigned to node.data of 05H. So, 05H referencing to node.data equals Lian. Lian. Patikit. Okay? Next. Mukha bang Lian? Lian. Next. We're going to assign value for this. Okay? The value should be the value of the head. So that means we're going to assign the value of head to node.link of the address of new node. Again, head is 07H. Okay? Ayan, head is 07H is equal to node.link of the address of new node. Okay. So, 05H referencing to node.data, 05H referencing to node.link is equal to 07H. 07H. Okay. So that means this one will now be linked to 07H. Okay? So, dahin lang natin ito ha. Ang process na to. So, Lian will now be connected. 07H na tinuturo niya. Ito yun. To this next node. Okay? So, however, our head still points to 07H. So, we have to assign a new value instead of 07H, yung head natin, okay, magiging yung address of the new node. Okay? So, head is equal to address of new node. Address of new node is 05H. So, 05H, parang hindi naging 5, no? 05H will be assigned as the head. Ayun. So, head will now be 05H. So, this now will be the head. Okay? So, ito, mawawala na yung reference sa kanya. Alright? Question. None. Very good. Next. What if we're going to insert a node at the tail? Okay? So, that means we're going to insert at the last node. Okay? After the last node. After the tail. Okay? So, as you can see, the first two processes the same. Create new node for the element. Set node.data or set the data field of the new node to the value to be inserted. And then, eto naman, may iba, no? So, you're going to set the link field of the current last node, okay? So, yung current last node or the current tail, the node that link, okay, the link field of that current tail will now be uh, the address of the new node. Okay, so or simply saying that the address of new node will be assigned to the link field of the current tail. Okay, and then of course we have to set the link field of the new node to null. Uh, Set the link field of the address of new node to null because that new node will now be the tail. And then you're going to assign tail as the address of the new node. Okay? So, pseudocode. Alright, so let's simulate this pseudocode. Okay? So, we're going to insert a new node at the tail. So that means the newly created node will be inserted here at the last part of the linked list. Okay? So what will happen before we simulate that pseudocode? Okay? So the procedure will be you're going to create a node, a new node, and then let's say the address is 20h. Okay? And then you're going to assign the new value. Let's say the new value is angel to the address of the new node. Okay? And then you're going to set the link field of that new node to null. Madali na. Bakit i-assign na as null? Because that is the last element. Okay? So what will happen here on our previous tail, okay, that would be a change. So, the current tail, the node that link of the current tail should be linked to the address of the new node. Okay? So, this will now be 20h. Okay? And then instead of assigning this as the tail, we will assign the new node as the tail. Okay? So, that's the procedure. Okay, let's try to simulate kung parehas pa rin yung lalabas sa ginawa natin. Okay? So, first, we're going to create, let's have the input parameters, no? We have the tail and the new value. Okay. So, the input parameter this time is the tail. So, you don't need to traverse from head down to tail. Okay? Because you could assign the tail. You could simply determine the address of the tail. That is because you have um, every tail, or when we say tail, it is the last element of the linked list. So tail now is 19h. Mhm. Okay, tail is 19h. Currently, it is 19h. And then our new value, let us say angel. Okay. So, same process. We're going to create new node. Okay. Let us say address is 20h. Next, set address of new node referencing to node.data to new value. So, our new value is angel. And we're going to assign angel to, node.data of the address of new node. So, address of new node is 20h. So, 20h referencing to node.data equals angel. Okay? Next, we're going to assign null. Okay? We're going to assign null value, okay, null, to node.link of the address of new node. So, address of new node is 20h. 20h referencing to node.link, ito yun, is equal to null. Okay? Next, set tail referencing to node.link to node to address of new node. Ito yun. Ito yung ginawa natin. Okay? So, paano gagawin? Address of new node is 20h. So, 20h will be assigned to node.link of the tail. So, our current tail is 19h. So, that means 19h referencing to node.link, 19h referencing to node 19h referencing to node.link is equal to 20h. Tama, di ba? So, naka-reference na siya. And then, we now assign tail is equal to address of new node. So, we assign the address of new node, which is 20h, we assign 20h as our new tail. So, tail, initially, ang tail natin is 19h. So, ngayon, na-assign na natin na 20h. Therefore, hindi na ito ang magiging tail at ang tail na natin is itong bagong node. Okay? So, we have now inserted a new node at the tail. So, what about if we're going to insert at the position I? Okay? So, that will be your assessment. Okay? So, moving on to our last operation, that is deleting a node at a certain position. Okay, so let us say we're going to delete node at the head of the single linked list. Okay, actually we have two ways of deleting a node or removing a node from the single linked list. Okay, so we could remove it temporarily or we could remove it permanently. Okay, so removing the element temporarily, all we have to do is to simply remove the link, okay, to of that node to the rest of the nodes. Okay, so we call that as temporary deletion, okay, or we call that as logical deletion. We just have it logically deleted, but still it is present or it is stored in the memory. Okay, nandun pa rin siya sa memory. It so happened that we just remove the link from the rest of the nodes of the list. Okay? But if we want to delete it permanently, that means even at the physical storage, we want to delete that node, all we have to do is to execute this statement, this keyword free. Okay? Free. Yan. This is a reserved word in a programming language, okay, in most programming language, that refers to a memory location. Okay, so if we have that free and then you specify the memory location or the memory address, whatever is inside that memory address, it will be permanently be deleted. Okay? Sabi ko nga parang love life lang yan, you know? Sa love life, di ba, meron tayong permanent at saka temporary deletion, okay? So, temporary deletion, kunwari nag-break up kayo, okay? So, temporarily, dun sa breakup ninyo ay wala mo na kayong communication or parang nag-cold off, di ba? Cold off muna kayo. Wala mo ng communication. Okay, so that is a logical deletion, okay? Temporary. But if you want to permanently delete that person, you want to free that person, so you have this permanent break. Okay? So that means talagang pati sa puso mo tinanggal mo na siya. Okay? So that is the physical deletion. Okay? So that is a permanent deletion. Okay? So to delete a node at the head, okay, going back, if we're going to delete at the head, you simply delete that node at the head of the list. Set the variable head to the address stored in the link field of the node to be deleted. So, paano nga iyon? Let us say, we have here the linked list, okay? And we want to delete this head, okay? So, if we want to delete the head, we have two ways. We have the temporary deletion. Temporary deletion is simply we remove the link, okay? So, to remove that link, all we have to do is, ganito lang siya, all we have to do is, tanggalin natin yung 20H, papalitan na lang natin yon ng null. Yan. So, this is a temporary deletion. So, mawawalan na ng link. Yan, mawawala na yung link dito. Yan. Sorry. We would have that temporary deletion. Ayaw. Yan, mawawalan siya ng link here. Okay? Because we just assign no.link of the head to null. Okay? But, we have to make sure that our head, okay, hindi tapa, etong top dito yan sa kabila, sa tail. Our head will now be 20H. Okay? So, before you delete any node, be it temporary or permanent, or permanent, you have first to assign the address of the head, okay? So, that means of the new head, okay? So, you have to refer to know that link of the head and that will be assigned to the new head, okay? Paano nga ulit yun? Simulate natin, ganito lang siya kadali. Okay, so going back, if we're going to delete the node at the head, that means we're going to delete the head, okay? So we have to save the address of the current head, okay? So let us say, for our input parameter, our head is 12H, okay? So 12H. So we have here in our memory, we have head is 12H, okay? And then, sabi niya, set node address to head. Okay, we will assign a variable that would store our head, our current head. Okay, so 12H will be stored to node address. Okay, so node address would be equal to 12H. Okay? Next, set head to head referencing to node.link. So, first, dun sa sa right side ng equal sign. Okay? So, sa right side ng equal sign, ito yung head referencing to node.link. So, we have to change the values for that. So, head is 12H and node.link of 12H referencing node to node.link is 20H. Why do we have to do this? Okay? Because we have to assign 20H as our new head. 20H, this one, as our new head. Okay? So, we have head is equal to 12H referencing to 20H. So, 20H will now be the new head. Okay? So, this will be the head. And then, we have a diretso na kagad, no? Physical deletion kagad. Free node address. So, node address is 12H. Yan. So, 12H, ito yung 12H natin. That will be freed. Ibig sabihin, That will be deleted. Ayan yan. That will be deleted from our lists. As in, permanently, tinanggal mo na siya. Wala na. Wala nang bakas na lumipas. Wala nang link. Okay? Tapos na. Okay? So, you free it. Okay? So, physically, we have deleted the head. Okay? So, ganun lang kadali. And what if we're going to delete at position I? Okay? So, that means the value of the I should be from its either or any of the position, within the position or within the length of the linked list. Okay? So, where I is less than or equal to n, where I is less than or equal to n, but it is greater than or equal to 1. Okay? So, how are we going to delete a node at position I? So, first, we have to determine, first determine the preceding node. Okay? So, we have to know the I minus 1. So, let us say, if our I is 3, okay, so we have to know the previous position. Okay? Why? Because if we want to delete this node, okay, if we want to delete this node, eto yung i-delete natin, dapat itong node.link na to ay yung node.link nung i-delete mo. Okay? So, dapat yung previous node, makuha niya yung node.link, yung value na node.link nung i-delete mong node. Okay? So that it could have a reference to the next node. Okay? So that is why you have to determine the preceding node. Okay? So if our I is 3, and then you have to get the second position. If our I is 2, then you have to get the first position. So lagi lang siyang I minus 1. Okay? Alright, so this is now the pseudocode of deleting an element at the ith position, okay, or node position. So, in our input parameter, we have the head and the I, or the node position, okay. So, our head, the value of our head is the address of the first element, so that is, first node, that is 12H. And our I, let us say we're going to delete the third element, so I is 3. Okay, so let's have a separate here. So we have the head. So we have here head. We have the eye. Okay. Okay. So head is initially 12H. And our eye, our desired position is at position 3, the third node. Okay, we want to delete this third node. Okay. So, as a first rule, we have to determine or get the previous element of the desired position. Okay, so we have to set I to I minus 1. So, if our I is 3, then we have to decrement that by 1. Okay? Minus 1. Ito yung kanina nating diniscuss. Okay? And then, set counter to 1. Why do we have a counter? We have to have a counter in order for us to know how many position or how many nodes have we read. Okay? So, initially, counter or CTR is equal to 1. And then, we have our next node. Next node, so next node is equal to next node is equal to head. So head is 12H. Okay? Next. While counter is less than 1. Counter, CTR is 1. Sorry, less than I. CTR is 1 and I is 2. Is 1 less than 2? Very good. True. So if it is true, let's have this increment counter. So increment CTR. So CTR will now be 2. Okay? And then set counter, set next node to next node referencing to node that link. So next node is 12H referencing to node that link. So what's the node that link of 12H? Okay, very good. We have 20H. So 20H will be assigned to the next node. So next node will now be 20H. Okay? Next. So, ito lang yung part ng while loop. Okay? This is the part of the while loop. So, it goes back to this condition. CTR is 2. Is 2 less than 2? False. Very good. So, if it is false, we have to execute the next statement. Set node address to next node referencing to node.link. Okay? So, next node is 20H. Referencing to node.link. 20H referencing to node.link is 31H. So, 31H will be assigned to node address. So, we have a new variable, node address, and the value of our node address is 31H. Okay? Next, set next node, okay? Referencing to node.link to node address referencing to node.link. Ano nga ulit? Paano yun? Ulit. So, we have here, parahin muna natin ito, ha? Para hindi kalito. Okay? Set na yan. Tapos, yung 2, gagawin natin siyang equal. Equal lang yan. Okay? So, all you have to do is to assign first the values. Okay. Unahin natin nasa right side ng equal sign. Ito yun. Node address referencing to node.link. Node address is, ito po, 31H. So, 31H So, node address is 31H. Referencing to node.link. So, 31H referencing to node.link, that is 16H. So, 16H, okay, will be assigned to node.link of next node. So, next node is 20H. So, 20H referencing to node.link is equal to 31H referencing to 16H. So, it simply says that 16H will be assigned to node.link of 20H. Again, 20H referencing to node.link, 20H referencing to node.link is equal to 16H. So, this time, magiging 16H. So, ito magiging 16H. Yung 31H, wala na. Okay? So, that means there is no more link here. Okay? Burahin natin yung link. Okay, wait lang. Burahin natin yung link dyan para makita nyo na nabura na siya. Oh, yeah. Okay. So, 16H, that means it refers to the address 16H as our next node. Okay? So, what will happen? Okay, we now have free node address. Node address is 31H. So, 31H will be freed. Ito yun, 31H. Itong buong to, mawawala. Okay? So, itong buong to, mawawala siya. Wala na siya. And of course, the link will also be deleted. Okay? So, this is how we delete an element at position I. Okay? So, if you have questions, just send me a message. Okay? So, lastly, we have now doubly linked list. This is just a preview, okay? So, doubly linked list is a linked list structure wherein it has a pointer pointing to um, the previous node and the next node. Okay, previous node is our predecessor and our next node is our successor. Okay, so as you have noticed, we have here two link field. Okay, one at the left and one at the right. So the left link field points to the address of its predecessor, while the right link field points to the address of the successor. Okay, so as you can see, we have here three nodes, okay, Lita, Che, and Renberg. And for each node, it has two link fields. Okay, so two link fields, dalawa. So, how do we refer to this one? Okay, so as you have also noticed, yung kanilang, they call that, the arrows are double-sided arrows because we are referring to and fro. We are referring to the predecessor and we are referring to the successor. Okay? So, ganito lang po siya. Okay? From first node, from 15H, okay, we refer to the right link field. Right link field is our successor. So, successor is 09H. Okay? And then 09H points to its successor, 19H. Okay? And then 19H points to no more. So, it's not. So, ibig sabihin, siya yung last node. And then 19H has a left link field. So, left link field naman niya points to its predecessor. So, ang predecessor ng 19H ay si 09H. Kaya, 09H to. Okay? So, ayun, pabalik sa kanya. While 09H, ang kanyang predecessor ay 15H. Yun nasa left link field. So, 15H, ito yun, 15H. Okay? At si 15H, wala na siyang predecessor. Kaya, null. Okay? So, that is the structure of a doubly linked list. Okay, but the operations of this doubly linked list will not be discussed because, as I have mentioned, we will focus only on a single linked list. Okay, so that's all for the linked list. Just send me your questions if you have questions or clarifications. Thank you and God bless.